Greetings to you everyone. Happy to catch you all in this video lecture on nuclear magnetic resonance, which is one of the indispensable technique to study the physical, chemical, structural information about biological macromolecules as well as other chemical molecules in general. We are going to see three aspects of NMR. First one, principle being NMR. Second aspect, instrumentation and experimentation of NMR technique. The third aspect, we are going to see few applications of nuclear magnetic resonance. Before we proceed further into principles behind NMR, I want you to understand a few basic information related to NMR. I always emphasize you to understand the meaning of each and every word in a technique, to understand its technical principle and relevant applications complying to the same logic. You are finding three words on the board: nuclear magnetic resonance, which is literally abbreviated as NMR. To understand the logic of this technique from the word, nuclear, you are going to study the response of an atomic nucleus under the influence of magnetic field in the form of resonance. This is what it literally means. To make it a bit more colloquial for your understanding, you are standing in a place, all of a sudden your friend comes near to you and give a tight slap on your cheek. How do you respond? Just take another case study. You are standing in the same place and some stranger comes near to you and gave a tight slap on your cheek. How your response will be? The third case query. All of a sudden, when you are standing in a place, you are being slapped by an enemy of yours. How your response will be? So definitely there will be change in the level of your response, although all the process is related in one way or another, slapping. So process may be slapping, but you are showing three different responses according to the person who instigated the act. The same logic is applied here. You are going to excite atomic nucleus with a magnetic signal, and you are going to see the response of atomic nucleus, and you are going to see the variation in the responses. Accordingly, you will try to find what type of atom are responding, and you are trying to understand the structural topology of atom in a huge macromolecular structure. Okay, so this is what you are going to do in this nuclear magnetic resonance. So here you are going to see three basic aspects. So as you see in the board, first one, the nuclear word is denoting the atomic nucleus. So atomic nucleus, you know very well. Each and every molecule is made up of atom. Each and every atom is made up of positively charged protons along with chargeless neutrons as well as positrons, boson particles. Around this atomic nucleus, your electrons are placed like a shell, in the form of shell, and these electrons are not static. They keep on circulating or revolving around the core atomic nucleus. So because of this movement of electron, the number of electron, the speed of electron determine the core energy level of entire atom. So when you are disturbing an atom with a surrounding stimuli means a surrounding stimulating condition. It may be a magnetic field or it may be a light field. In the case of nuclear magnetic resonance, I am using, or you are using, magnetic field to disturb the atomic structure. And what the atom does, it absorbs the energy and it tries to imbibe the energy into its structure. And during this process, the atom and its electron is excited to higher energy level. Always remember, higher energy levels are highly unstable. After some time, they try to come back to its original shape. And during this process, what happened? This excited stage, when it is coming back to lower normal original condition, excess energy absorbed by the atom is released into the surrounding environment, which is technically known as dissipation of energy. This energy may be in the form of temperature, or it may be in the form of electromagnetic radiation or electromagnetic frequency. So what is being done by exciting the atom with a magnetic field? You are exciting the atom and you are allowing the atom to come down to normal level. So depending on the amount of energy absorbed by the atom, the current energy released from the atom also varies, and you are studying the amount of energy released and you are trying to find out what kind of molecule it is or what kind of atom it is by understanding this concept called resonance. So resonance are literally defined as a response or reflective signal to of a particular atom against particular stimuli. That's what it literally means. Here you are studying the response or reflective action of an atom against a stimuli in the form of amplitudes. So this word amplitude you would have studied in your physics or chemistry during your undergraduation or school studies. Try to recollect it. So amplitude is basically the intensity of a signal that you receive from a substance or from an atom. So this intensity may be studied in the form of sound or light or temperature, whatever it is, but it will be shown in the form of peaks. For example, low intensity peaks will be shown in the small peak range. If it is high intensity response, it will be shown in the form of larger peak. Okay, so this peak range, okay, the time duration of the peak, that means like the time duration taken for the entire peak to go to the top level and come back to the normal level, it varies according to each and every atom. So by studying each and every peak, you are trying to study what kind of atom you have dealt, and what is the significance of this atom in your biological macromolecule or chemical molecule. For example, this peak may correspond to hydrogen and this larger peak may correspond to CH3. So what does it mean? If I do get a nuclear magnetic response resonance spectra, that's what we call technically, in the form of two peaks now, that means my molecule, the molecule which I have studied using NMR, has two basic structure. That is, one is hydrogen, another one CH3. So this is confirmed with the NMR technique. So then what is I try to do some analysis with which I shall try to study the physical, chemical, structural aspects of molecules. So this is what literally happens in nuclear magnetic resonance. Now we shall proceed further into a principle behind NMR technique. So the entire principle of NMR is surrounding one core concept called resonance frequency. Okay, so resonance, try to recollect this meaning, response or reflective action of an atom. So this frequency you know very well. So this is a kind of wavelength. So what kind of reflective action, in what wavelength it has been responded by an atom against a particular magnetic stimuli. So that's what we study in the form of resonant frequency. This resonant frequency differs between each and every atom. Sodium shall respond in one way, uranium shall respond in another way. In the same way, like your carbon shall respond in one way and hydrogen shall respond in one way. Each and every atom, they produce different peaks. By studying the intensity of each and every peak, I shall try to study what kind of atom it is, and by studying the arrangement, for example, if I am getting hydrogen first and carbon next up now, so there is a possibility I can come to a conclusion this hydrogen is located first and followed by carbon. So these two may be having a bond. Okay, so this forms CH structure. Okay, so we will study this in detail in later part of this lecture. So here I want you to understand one thing. Resonance frequency of atom is a core principle, and each and every atom has a reflective response against a particular magnetic stimulation. So before we go into detail, so what is the need to study, or what helps you to understand, what kind of understanding you will get from this resonant frequency study? There are three core aspects of this study. First one, you can determine the presence of different functional groups in a molecule. Okay, whether your molecule is containing hydrogen or not, whether your molecule is hydrogen containing CH3 groups, hydroxyl groups, alcohol groups are there or not. So you will be able to study the presence of different functional groups in a molecule. Second aspect is topology. You can study the order of atoms in a molecule. So just now I told you, by understanding the peak nature, you are trying to study the atom. By understanding the order of peaks, so I am getting hydrogen first, second, carbon up now. So after hydrogen, carbon comes. So then if I am getting another peak hydrogen again, what does it mean? So this literally means first one hydrogen is there, second peak carbon, third peak hydrogen has C gust. So actually I am trying to understand the topology of a molecule given in my hand. Okay, and third aspect, 3D structure of molecules. So by understanding each and every peak, I am trying to find the atom and its order. So as you know very well, atoms together they form molecules, and these molecules together they form macromolecules. So if I study individual atom, I understand the molecular organization. If I study the organization of individual molecules, I study the structure of entire macromolecule. So that's a third core aspect behind studying resonant frequencies of atom in a molecule. So I can construct a 3D structure of a biological macromolecule as well as chemical molecule. Okay, fine. So now coming to the core discussion of principle. So basically NMR works on the two important properties of atomic nucleus, that is intrinsic nuclear magnetic moment of atom, and second one, angular moment of an atom. Okay, so there is a considerable difference between these two. So your intrinsic and native. Okay, so the reality or real potential of particular atom, that's what you call intrinsic. So each and every nucleus, they have a proton and electron. Nucleus has a proton surrounded by electron. So they used to have their own magnetic property. So you know very well, each and every thing in this world which contains electron and a proton in its atomic structure, they tend to have this core electromagnetic property in their structure. So this is what we call intrinsic nuclear magnetic moment. And next one is angular moment. So this angular moment is a bit tricky. So one atom, okay, if you are drawing an illusionary plane like this, okay, so ஒரு illusionary plane அப்படிங்கிறதுனா நீங்கள் ஒரு ரஃபாக நீங்களாக imagination if you are drawing a diagram. Okay, so this is an atom, so there is a nucleus. Okay, so if you study, there is a possibility electrons may be placed like this on the same plane, or it may be placed in the sideways. Okay, so if you draw the structure so this is the real angular momentum of the nucleus. So this is the illusionary plane, and this is a real angular momentum of electrons in a nucleus. So that's what we call angular momentum. So this is these are the two fundamental physical properties of an atom being studied in nuclear magnetic resonance. Okay, so what exactly happens in NMR? You are creating a magnetic disturbance on this nucleus at particular radiational frequency or resonance frequency radiation. Okay, so you are giving a magnetic pulse. So you know very well magnetic pulse kodha enna theriyum. Just remember, if you are taking magnet near on your skin, you will feel some sort of attraction between your surface, skin surface and the magnet. So this is because of few attractive interaction between your macromolecules as well as other uh, metallic minerals present in your cellular system and the magnet. The same way you are going to subject the macromolecule for a magnetic disturbance at particular resonance frequency radiation level. Okay, so which literally changes the intrinsic magnetic moment and angular momentum of the atom. Okay, so for your example, let me draw this picture once again. So this is a atom and there is a nucleus. Your electron is placed like this. An illusionary line I am drawing, that's for my understanding. Okay, so I am finding it. So it's a normal condition of the target atom. For example, this is 30 degree. Okay, so angular degree is 30 degree. So when you are disturbing this atom with the external magnetic field, so what will happen? So this excited atom shall change its electron location. So what will happen? There is a possibility. So it may generate or it may have a electron linear momentum like this. So now earlier 30 degree excited condition, it may be around 70 degree. Okay, what does it mean? So this change in the angle is because of the absorption of energy from the surrounding environment, which is provided by magnetic flux. So this is what being done to change the intrinsic nuclear magnetic momentum and angular momentum of the atom. Okay, fine. So what happens next? So due to absorption of excess resonance frequency radiation by atomic nucleus, okay, so which is literally dependent on the nature of the atom. If it is hydrogen, it may be absorbing one particular energy level. If it is carbon, it may be absorbing the energy in another level, or due to the surrounding chemical environment. For example, if I am keeping the desirable macromolecule which is studied using NMR in a normal water, it may be absorbing energy in one particular condition. If it is being kept in ethanol, it may be absorbing the energy in another level. Or in the third aspect, location of molecule. For example, if I am studying the structure of protein, the protein is made up of amino acid. So the amino acids are made up of carbon, nitrogen and oxygen. Okay, so if I am studying one particular hydrogen which is located in 133rd location of one protein molecule, okay, so it may be absorbing energy in one condition. Okay, if I am studying one carbon molecule present in amino acid which is located on the surface of the protein molecule, it will be absorbing energy in particular amount. But if I am studying another carbon, okay, the same carbon, so which is located somewhere in the interior part of protein, okay, it will be absorbing energy in one level. So basically both are carbon, but location of carbon determines the amount of energy absorbed by the atom. Okay, so what happened next? The absorbed energy is allowed to be released from the atom after some time. So this process is called dissipation. This absorbed energy is again dissipated into the surrounding environment, either in the form of temperature or electromagnetic frequency or radiation frequency. So you are going to read this released energy using certain coils. Okay, coils are being placed in the surrounding environment, so which actually detects the change in the electromagnetic radiational frequency, and these coils generate the change in the form of electric signal, and this electric signal is in turn being producing spectral peaks. Okay, for example, electric potential is too low, it produces a small peak. If electric potential is too high, it produces a huge peak. So depending on the nature of atom and nature of energy released from the atom, the peak level also varies. So this is what you will be studying, and you will be studying each and every peak individually, and you will try to find out what kind of atom it denotes. Okay, then what you will do, you will try to locate the order of each and every atom, and you will try to find whether any interaction is there between these atoms or not. This is how you will try to construct one small molecule from few number of atoms, and you will try to construct a macromolecule with few molecular information. Okay, and how this is being done, this entire concept is being done based on three formulas or three conditional studies. Okay, first one, nuclear spin, just now I told you, I do not want to repeat it once again. So you will be trying to find the change in the nuclear magnetic moment and angular momentum by studying the nuclear spin change. I have explained it already. But second important aspect of this experimentation is resonance flip. Okay, what is resonance flip? So I told you, so if your normal atom is located in one particular angle, when you are exciting it, it is changing its angle and it is changing its momentum. Okay, for example, so 30 degree length, it has moved to 70 degree in I have just now told you. At the same time, the spinning nature of electron may also vary. Okay, so the electron, stimulated electron may run faster. So it means literally the energy level produced by the atom also exceeds in that condition. So this is what we call a resonance flip. Okay, so I told you, when you are being slapped by an enemy, you will be showing an aggressive response. But if you are slapped by your own friend, you will not be showing the similar aggressive response to your friend. You will try to think for a while. Okay, so this is the difference. Okay, this reflective nature is what we call resonance flip. This resonance flip is studied with three things. One is delta E, total energy level in the atom. Second one, V naught. Okay, so that is your voltage potential, that is the electric potential of your excited atom. And third one, the difference between the excited atom and the lower state of atom. Okay, so these three things are being studied in this concept resonance flip. And the first one, total energy, is being studied with this formula. And do not mug up this formula, just understand this one. So you know very well that you would have studied this formula is equal to h mu during your physics subject in 12th standard. Okay, so which literally means, you know, total amount of energy present in the nucleus. Okay, with the two things, one is Planck's constant h, another one mu is your voltage potential of your atom. Okay, that is electron potential of your atom. So you are going to study this h mu in this formula and using certain individual things. So one is your electron potential, electron energy potential in a normal condition or excited condition. Another one, your magnetic field potential. Okay, how much of magnetic field is given by you on top of this atom. And when you are substituting each and every value, you will understand the total amount of energy present in the particular atom. Okay, so if it is a normal atom, that will be having one energy. If it is excited, that will be having different energy level. Okay, and second aspect is voltage, electron potential. This electron potential is studied using this formula. Okay, so just now I told you. And while you are studying these two, you will be calculating another thing. So what is the total number of a total amount of energy in the excited level and the lower level of particular atom. Okay, so I will be studying these three, and I will be correlating the value of total energy in the excited stage and the normal stage, and I will try to find the difference, and this difference will be shown in the form of peak. Okay, then what you do, there is another thing called, third aspect called relaxation time. So what is relaxation time? The time duration taken by an atom to go to an excited state and come back to the normal condition. That's what you call relaxation time. So this relaxation time shall vary between atoms. For example, carbon hydrogen example. So carbon hydrogen, they may produce a similar peak height. Okay, ரெண்டு similar peak height இருக்க வாய்ப்பு இருக்கு. But there may be some change between these two atoms in their relaxation time. Carbon may take its own time to come back to normal level, so the peak would be too huge. But in the case of hydrogen, the peak may be subsidized quickly. Okay, due to its shorter or smaller structural condition. So this is what we call relaxation time, which is being studied with another formula. So what you do here, you are studying the change in the angular momentum first. You are confirming the electron is excited or atom is excited or not. Then once you have confirmed it, you are studying the resonance flip, in which you are studying the difference between electron potential of excited atom and the normal atom. Okay, and then you are relating this value with another concept called relaxation time. When you are integrating the resonance flip and relaxation time, you are getting peak. Okay, and this peak denotes one particular atom. Clear? So this is how nuclear magnetic resonance works on Kanna. So